All right, so today we're going to be looking at conic sections, but in polar form. So you do need to know something from the last section, which is the eccentricity. So parabolas have an eccentricity of 1. Ellipses are between 0 and 1. If it's a 0, it's a circle. And then hyperbolas are going to be greater than 1. So we're going to use that today to identify which conic section it is. All right, these are our 4 generic equations. And looking at the equation, it's E times D, which is the number that's in the equation of your directrix. And it's either going to be on the bottom 1 plus E cosine theta, or 1 minus E cosine theta, or 1 plus E sine theta, or 1 minus E sine theta. Now, these look like parabolas in the diagrams here, but they could be an ellipse, so this could continue this way. It could also be a hyperbola, where you'd have part of it going downward this way and then upward this way. Okay, so pause the video if you need to write these down. They're also in your book. And then we're going to do these 3 examples, 4a, 6a, and 8. And then we'll do the rest of the problems in class tomorrow. All right, so we're going to start with 4a, which gives us this equation, r equals 2 over 1 plus sine theta. So as a reminder, polar coordinates are r, comma, theta. So we have, this will be 0, pi over 2, pi, and 3 pi over 2. And you could keep going. This could also be 2 pi, and so on. All right, so first thing is, in our equation, we need to match up which one it is. So it's not the cosine ones. And since it has a plus, then it must be this one. So this is going to tell us that our E is the coefficient of sine. Now, since there is no coefficient here, E is equal to 1. All right, so since E is equal to 1, we know for sure it's a parabola. Now, the book says graph the parabola. Sometimes they don't tell you what shape it is, but we just confirmed that it definitely is a parabola. And since, according to this diagram, the directrix is going to be a horizontal line above the origin, then we know this has to be a parabola that opens down. Okay, the nice thing about this equation is we don't have to divide anything. If this number isn't 1, you have to divide them all by whatever this number is. All right, so we're going to just start writing down some information. So we have the eccentricity. The directrix, we can tell by this. This is E times D equals 2. And since E is equal to 1, we know that D equals 2. So therefore, our directrix is a horizontal line at Y equals 2. So I'm going to put that on my graph. All right, and the nice thing about these equations is that all of these have focal points at the origin. So you have a focal point. Now in a parabola, there is only one focal point. In an ellipse or a hyperbola, there's 2 focal points, or foci. So this is going to be at 0, 0. All right, and as a reminder, from any time we're dealing with a directrix and a focus with a parabola, the vertex should be right in the middle. So if we went from 0, 0 to 0, 2 and found the middle, that tells us that our vertex should be at 0, 1. Now we're going to graph it a little bit in polar and a little bit in rectangular form. So we're going to put the equation in our calculator, which we have here. 2 over 1 plus sine theta. Notice I grouped the bottom. All right, and then we're going to graph it. So there's our parabola opening down. Right? Looks pretty good. And if we go to our table of values, now in order to make this table set up, I had it start at 0 and it counted by pi over 2. That's what this 1.57 is. Okay, so my table of values, your calculator likes to say theta comma r. I don't know if that makes it difficult to graph or not, but theta and r. So at theta, or at 0, pi over 2, pi, 3 pi over 2, and we can just go to 2 pi. That'll be fine. So we got 2, 1, 2. It says error, so that means there's no point there. And at 2. All right, so if you graph this, remember in polar we have, so at 0 degrees we go two circles outwards, right? Here at pi over 2 we go 1 circle outward, which makes sense because that matches up with our rectangular coordinate of 0, 1. At pi, we're at 2. Now remember, you're 2 radii, 2 units of a radius of a circle away, so that's over here. And 3 pi over 2, there is no point at 3 pi over 2. And then at 2 pi, we're back to this point. So remember, it was a parabola, so we have actually enough information to graph. Now you could have just graphed it, instead of looking at the polar coordinates, you could have also figured out that P is the distance between the focal point and the vertex, which is 1, right? And then the vertex and the directrix should also be a distance of 1. And the focal width should be a grand total of 4, because this would be 2p and 2p, so 2 times 1 and 2 times 1. So it all matches up. All right, so just to double check what the book asked you to answer, it says, specify the coordinates of the vertex in rectangular form, so that would be this. If we needed it in polar form, it would be 1 is the radius and pi over 2. But it did ask in rectangular form. And it also asks you for the equation of the directrix, which we have. So that's y equals 2. And we graphed it. All right, so we're all done with 4a. All right, next problem, we have 6a. So that gives us r equals 3 over 3 plus 4 sine theta. All right, so we can match up which equation it is. It's this one. Again, same one. Right? It's got sine. It has a plus sign. So it must be this one. Now the issue is this is not a 1. So because it's not a 1, we need to divide everything in the equation by 3. Right? As long as you divide the top and bottom by the same number, you haven't actually changed your equation. So now this becomes 1 over 1 plus 4/3 sine theta. All right, so this tells us enough information for us to graph. Right? E is equal to 4/3. So if we look back at our notes, if E is greater than 1, it must be a hyperbola. All right, so this is a hyperbola. All right, E times D should equal whatever number's in the numerator. So 4/3 is E, D we don't know, and I need to multiply by 3 and divide by 4. So D is equal to 3/4. All right, and according to this generic one, my directrix is going to be a horizontal line, which is 3/4. All right, so I can graph a little bit so far. I know that at 3/4, we're going to have my directrix. And at 0, 0, we know we're going to have a focal point. All right, so now to get some more information, we need to figure out some of the values in our table. All right, so again, we're going to graph in our calculator. We can have it come up with the coordinates. So we need to change our equation. Actually, you can use either form of the equation. So this one might be easier to type in. So I'm going to type in 3 over 3 plus 4 sine theta. All right, I'm going to hit graph. Okay, now your calculator likes to connect points, so it's actually nice. It kind of shows your asymptote. So here's the bottom part of the hyperbola, here's the top part, and we're looking at our table of values. Okay, so we have, this is 1. Now, this is 0.42, and I know that this is actually 3/7. 1, -3, and back to 1. All right, so that should be enough for us to graph. All right, so at here's 0, we're going to be 1 unit away. At pi over 2, we're going to be 3/7. Now this was 3/4, so that's 0.75. This was 0.42, so we're going to be a little bit less than that. Pi, no, that was pi over 2. This is pi. We should be 1 unit away. All right, so these are symmetric. And at 3 pi over 2, now this is something to remember from polar graphing. We don't want to be at 3, we want to be at -3, which means you cross over the pole. So this is 1, 2, 3. All right, that was our other half of our hyperbola. And so we can connect. It's not the greatest hyperbola graph, but at least we know here what our graph should look like. All right, so this is our transverse axis, right? And these are our vertices. One thing to help us find some information is we should find our center. So we'll write down our vertices. In rectangular form, right, this would be at 0, 3/7 and 0, 3. In polar form, they were over here. All right, my center should be right in the middle, so I just need to find the midpoint. So remember, midpoint formula is x plus x divided by 2, so that's 0, and then I need to do 3/7 plus 3. 3/7 plus 3 divided by 2. And that gives me 12/7. So my center is at 0, 12/7. So about 1.7, which is here. All right, and then let's just double check what it asks us to identify. So it says find the eccentricity. We had that right away. Find the center. We have that. I guess we didn't need to write down the vertices, but you needed those in order to find the center. And then it says find the values of A, B, and C. All right, so A is the length of the transverse axis. Okay, so the distance between the two vertices, that's our 2A, right? So 2A is equal to the distance between these 2 points. So since the x-coordinates are 0, we can just subtract 3 minus 3/7. Right, so 3 minus 3/7 is 18/7. So 2A is equal to 18/7. And if I divide that by 2, that gives me 9/7. All right, so A is equal to 9/7. So that answers another question. C, if you remember about hyperbolas, is the distance from the center to the focal point. Now the center, we determined, is 0, 12/7. The focal point, one of them, is at 0, 0. So this distance is C, and that is 12/7. It's easy when the focus is at the origin, right, because it just subtract. All right, so now we know C is equal to 12/7. And then for a hyperbola, you use basically the Pythagorean Theorem to figure out what is B. So we have 12/7 squared equals 9/7 squared plus B squared. All right, so if we solve that, we're going to get 144/49 equals 81/49 plus B squared. So 144 minus 81 gives me 63. So B squared equals 63/49. And if I square root that, then B is going to be equal to the square root of 63. So that is 3√7/7. All right, and then we've identified everything. So eccentricity, center, A, B, and C. And we have a graph. All right, last problem is problem number 8. And problem number 8 gives us R equals 16/10 plus 5 sine theta. Oh, I didn't mean to pick all the ones that kind of matched up with the same generic equation, but you get the idea of what to do. All right, so this one matches here. Right? We know that this should equal 1 at the beginning, which it doesn't, so that means we need to divide everything by 10. So now we're going to have R equals 1.6 over 1 plus 1/2 sine theta. All right, so E is equal to 1/2. And if you double check what your eccentricity tells you, is that this is an ellipse. Okay, so I know that this is an ellipse. And, oh, we could graph our directrix. I think that would be helpful. So E times D is going to be equal to 1.6. If I know that E is equal to 1/2, then if I multiply by 2, I get D to equal 3.2. And then according to this generic equation, the directrix is a horizontal, and it's Y equals 3.2. All right, so we have our E, we have our directrix. We have 3.2. Here's my directrix. And if you remember the ellipse, the directrix is outside, so your ellipse is going to be over here. And then we're just going to plot it in our calculator to get a table of values, and that'll help us find some points. So I'm just going to put in the original equation, 16 over 10 plus 5 sine theta. All right, so I am going to graph that. And here's our ellipse, so we're going to eventually get our graph on our paper. So if I look at my table of values, I have theta and r. We have 0, pi over 2, pi, 3 pi over 2, and 2 pi. So this is 1.6. 1.06 repeating is 16 over 15. This is 1.6 again. This is 3.2 and 1.6 again. All right, so if I graph it, I remember one of my focal points is at the origin, so 0 and 1.6. Nope, sorry, this is in polar. 0 and 1.6. Pi over 2 is 16/15, which is 1.06, I guess. Should be more like down here. Pi is at 1.6. 3 pi over 2 is at 3.2. And then at 2 pi, we're back at 1.6. So this is sort of your ellipse. I know it's not it's not a great shape, but we don't have that many points to connect. All right, so the thing that we know about our directrix and ellipses, we have another one down here, but we know that this is going to be our major axis, the vertical from here to here. So the vertices in rectangular form are 0, comma, if we're looking at our pi over 2 and our 3 pi over 2. This is 16/15. And our other vertex is at 0, comma, negative 3.2. Now these are our polar coordinates in rectangular. You just look at this as x and y axis, right? The major axis should be 2a, which is the distance between these 2 points. So if we wanted to find the distance between these 2 points, we could just subtract. So we have 16/15 minus negative 3.2. All right, so 2a is equal to 64 over 15, and if we divide that by 2, a is equal to 32 over 15. All right, we also know that the distance from one of our focal points, which is 0, 0, to the center should be equal to c. So now it means we need to find our center. Now our center should be the midpoint of the 2 vertices. So if we add them up, so if I find the midpoint between 0, comma, 16/15 and 0, comma, negative 3.2, that's going to give me 0, comma, and then I have to add them up and divide by 2. So 16/15 plus negative 3.2 and divide by 2 is negative 16/15. Sorry, there you go. So about negative 1.06. So there's our center. And hopefully that graph looks okay. All right, so we need to find the distance between the focus and the center, because that'll give us our c value. So the distance between this is 16/15. All right, so since we have that, now we can find our b value. So let's just double check what the question is asking us. It first says, figure out which conic section it is, which we determined by our eccentricity. All right, then, now since we know it's an ellipse, it says if it's an ellipse, you specify the center and the eccentricity, which we have. the lengths of the major and minor axes. So actually we don't need A, we need 2A. So this is our major axis. But we need to find B in order to find the length of our minor axis. And then that's all we need to find. All right, so in an ellipse, remember it's c squared equals a squared minus b squared. So we're just going to plug in our numbers. 16/15 squared equals 32/15 squared minus b squared. So we have 256 over 225. 32 squared is 1024. And if I subtract, b squared is equal to 768 over 225. So now I have to take the square root of that. So the square root of 225 is 15. The square root of 768 I'm going to run my a quad program, and my radical is 768. So 16 root 3. All right, so since I need my minor axis is 2b, so I just have to double that. So it's going to be 32 root 3 over 15. So that's the length of my minor axis. All right, and then I believe we have answered all the questions. All right, so the ones that we didn't do as our examples, that's what we're going to continue in class tomorrow. Okay, have a good day.